How long do you think it would take to scan down 2 columns of a 350,000 row table, replacing all the values that you've provided in a list? 30 seconds, a minute, 2 minutes? What if I said 5 seconds? Well, I've compared 7 different methods, and a couple of them are 5-second refreshes. I'll make this file available and I'll run through a couple of those methods. Let's go. This is a video that's longer than normal. I go into a lot of depth about how the queries work and the speed of refresh. So if you just want to jump to the relevant sections, expand the description and you'll be able to see the various sections along there. You can just jump to the one that interests you the most, i.e. the one that refreshes quicker. All right, hope you enjoy this. I learned a few things. I've done a few different examples here. So let me show you, okay? And I'll talk you through the core concept. And I'll show you a few of these examples, but not all of them. But you can download this file and take a look at how they all work. Let's just change the data size to 350,000 records. Okay, and I'm just going to show you this method here, which I'll talk you through in a second, is using a simple merge. Okay, it's merging this table onto the side of this table and then doing like if there's a match, pick the value from the replacement table. But check it out. Right click, refresh. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 seconds, but I've just opened this file. If I rerun it a second time, it's going to be a bit quicker. But let's say 10 seconds rather than 4, okay? Then I did one with a couple of different formulas and things, trying to be a bit fancier rather than a boring old merge. And the refresh was like 130 seconds. Okay, the formula looked elegant, but the refresh was slow. I'll show you that in a second. Those were both exact matches. So Apple is replaced there. So I've replaced, let me just go back here. A got replaced with Apple, but space A didn't, nor did something A, and nor did capital A. Whereas over here, I've done a single column partial refresh. Okay, and again, this one was just a single column. I was just replacing, you could do multiple merges, gets a bit painful. This one was a partial match. So again, you can see that Apple has been replaced in all 3 scenarios and here as well. So all 4 scenarios. So that's ignoring the case. So it doesn't matter whether it's uppercase or lowercase. It's also doing a partial match. So it doesn't matter whether Apple A is on its own or after something. 170-second refresh. Okay. But it's essentially quite a simple formula. Okay. And then check this out. This is the good stuff. Multi-column refreshes. Some simple ways, some funky formula ways, very long refreshes. But then 2 of these, one that was an exact match with a single formula, a single line of code. It's a longish formula, but it's a single one. Okay, 5-second refresh. And a more complicated List.Accumulate, which can also do a partial match. Again, 5 seconds. As long as you remember to use List.Buffer. Otherwise, it's 180-second refresh. Okay, so let's take a look. We'll start with the very first one. I'll quickly skip through the other ones without going into detail. And then we'll have a little look at these last ones. All right. I loaded this source table. So I did right click, get data from table/range. I also loaded the find and replace, right click, get data from table/range. And they're now both in Power Query. I've got a little button to go to Power Query. You can do Alt F12 to open Power Query. There's 100 ways to get in there. If you haven't done any of those things, data, get data, launch Power Query. But honestly, just right click and add it to your quick access toolbar because you're going to be clicking on it a lot. Or remember Alt F12. Okay. Okay, so here's the data brought in. Okay, the big table, 350,000 rows. I just did a little subset for testing, 8 rows. Okay, not that that really matters. And this one, table replacements. Okay, this is the from and the to. So let's just have a look at the merge one. So here's the source step, which is just the 8 rows of data, just for demo purposes and keep things quick. I then did a merge, okay, which is under the Home tab, and when this isn't, this normally, if you go full screen, this is just merge queries, okay, which is this step here. If I click on that, essentially you've picked the column that you want to grab from the original, you pick the column that's the sort of lookup column, and you do a left outer join, which is the default. Then you click OK. Okay. Then you click this little button, which is the expand button, and that brings up this item, and you just say, I just want to bring back the replace column, don't need the find column. Okay, and then we just added a custom, so we said add column, custom column, and all that is doing is saying if the replace column, okay, equals null, because where there's not a match, okay, it's null. Otherwise, grab the value from the item column, which is the original column I was after. Okay, otherwise replace. So if it's null, use the item value, otherwise replace. And that's it. Okay, pretty straightforward. Remove the other columns. Rename that one to item 1, or just item. Move the columns around. Job done. Okay. The next one, that was a 130-second refresh. Let's just have a look at the code here. This was pretty funky. I like this as a concept, but the 130-second refresh really puts me off. The merge is just way better. So if I actually go to the advanced editor, okay, here's the code. So basically it's using, this is handwritten code. So it's using the table replace value function, okay, referring to the source step, which is essentially just the table of data, okay. And then it's saying, hey, for each item, so go down that column of items, go to the table replacements, that was that table, okay, and there was a column called find, and basically you're going to filter that table. This little syntax essentially allows you to sort of grab the record where find equals the item name, and then use the replace, the corresponding value from the replace column. Replacer text, item. Okay, an item is the name of the column, so it's this column that you're replacing. So a little bit quirky. Take a look at that code. I thought it was pretty neat until I actually refreshed it on 350,000 records, and it was pretty slow compared to that merge approach. So, and let me just remind you of this. Okay, that's the 2 columns, find and replace. So essentially that little example, let me go here, okay, if I filter the find column for the letter A and put replace, it puts apple. So essentially it is going into here, filtering this, it's not really filtering, but it's grabbing the record that matches that. So it's grabbing this and grabbing the corresponding replace item. Okay. It's not really a technique I've ever seen before, so I was quite interested by it. But what if you want to do sort of partial matching? Because that only works for exact matches. Well, then there's the next option. This was the 170-second refresh, but you can ignore case, you can do partial matches, so it is pretty flexible. So again, source is just the data, and then we add this custom column, okay, and this is a little bit gnarly. All right, but I'll talk you through it. Again, you can download this file. Okay, let me talk you through this. Really, it starts in the middle bit here. So let me go here. So we start in the middle. We're doing a text split on the item column. So the item column, something A would be split into a list of something and A. So all the words get split apart. I guess the more words there are in the column, the longer this refresh will take. So that's the first bit, okay, text split item. Then we're going to do a list replace matching items. And that function, okay, needs a list, which is the text split, okay, and then it needs another list, which is the replacements, which consists of pairs, essentially what you're changing from and what you're changing to. And to create that one, I've just used this function, table to row on table replacements. Let me just show you what that does, because that comes in handy later as well. I'll just do that, right? Let me just go cancel. I'll come back to this in a second. All right, so let me right-click and reference this just to create a new query. Okay, table to row, table replacements, just as this. So it turns it, if I click on this, see how that row, A and apple, B and berry. So it's basically turned it into a list. So that's the replacement. It finds that, replaces it with that. So that's what that table replacements part is doing. Okay. So let me go back here and go back into the added custom. Okay, I'd put that on a separate line. So we're saying take this list, breaking it apart, and replace it with the values, the matching values from that list. And that really does it. Now the nice thing about replace matching items is you can also add this optional parameter, which ignores case sensitivity. Okay, I just type in ignore because I can never remember it. So it says, it comes up with that, compare ordinal case ignore. Okay, and then ultimately that creates you, I'll show you. Let me just get rid of this. Get rid of that little bit. Get rid of that last little comma. If I just have that, okay, so without it, you just get this list, like something A becomes something apple. Right, so putting the text.combine back in with space between each word, okay, that then actually returns the words with spaces in between rather than the list. And then it's just a case of removing the item column, renaming this one as item, and then reordering them. Beautiful. Okay, so that's a 170-second refresh, but partial match and the ability to ignore case, but a single column. Okay. Right. Let's take a look at the multi-column matches. And this is where it gets good. We have got the ability to refresh in about 5 seconds. Now I've tried a few times, it's somewhere between 10 and 5 seconds. This one for multi-column with an exact match, but the ability to ignore case. Okay, that's a single line of code, which is pretty awesome. This one, more complicated code using List.Accumulate. And you have to use list buffer, otherwise it's very slow. I'll talk you through this. Again, 5-second refresh for a partial match. So, something A becomes something apple. Or space A becomes space apple with that partial match. With this one, capital A becomes apple, but space A doesn't get changed. Okay, so let's look at these. I'll also quickly show you the unpivot one as well. All right, so let's go back into it. Alt F12. Okay, the first one is the unpivot method. So you just bring in the data, you right click and unpivot other columns. Basically then you're back to the single column techniques, and you can use any of these ones with the partial matching, etc. But you know, if you've got 5-10 columns and you've unpivoted a 350,000 row table, that's then 3.5 million rows if you've done 10 columns. I think this is going to be slow. Okay, in this one I just did the replace. Let me just collapse this. Okay, I did the replace using that single sort of formula technique, which is pretty cool, but I could have used the add column and text split method as well. But it's going to be slow. Okay. Then there was what looked like a beautifully elegant single line of code method. All right, check this out. So it's a Table.Transform columns, looking at the source data. Okay, skipping any specific column, that little first parameter, you can say, hey, for this column, do this transformation. For this column, you can put a list in there of columns and the transformations. Or the second part of it, after the comma, is for all columns, like the default. And that's what we're using here. We're saying for all columns, do the list.replace matching items. Great. For each item, and we're going to replace it with, okay, the table to rows table replacements that we saw before. I'm not really convinced on this. This is grabbing the record from it to blow it out into a table. Without that, let me show you. Okay, it looks like this. So I'm not quite sure how this 0 bit grabs the first item from every record in there, I guess. So I thought that was brilliant. But then when I refreshed it on 350,000 rows, it was a 540-second refresh. Okay, so not great. And I guess the more columns you have, the slower and slower that's going to be. Okay, so looks cool, but not sure I'm going to recommend that one. Then one of the nice ones, the 5-second refresh. Check this out. This is pretty cool. So this is a 5-second refresh. Ignore this bit to start with, table from columns and table column names. That's just basically taking your results of what's about to happen and then turning it back into a table and adding the column headings from your original table. Okay, that's what that outer bit is doing. The clever part is the inner bit. So we're doing a list transform. Okay, we're grabbing the table source data and then turning it into a list using table to columns. Let me just show you what that looks like so you can picture this in your head. That's what really helps me to understand this stuff. And again, I'm not writing this stuff from scratch. I'm Googling it, I'm finding versions, I'm using ChatGPT, but then I want to understand what it's doing, okay? So if we went to table source data, let's just go right click refresh just to create, reference, just to create a blank query. Okay, and then I'll paste that in, equals. So there's my source data, but if I say 2 columns, it just creates a list. So each column, 1, 2, 3, 4, that's the first column, that's the second column, that's the third column. So table 2 columns just creates a list of lists. Okay, let me go back here. So 1, 2, 3, 4, so on. Okay, all good. Right, so if I go back into this single line of code, advanced editor. All right, so basically List.Transform, let me just bring that up, requires a list and then a transform function. So the list we've just given it is that list of columns. And then for each item, it's basically going to do a list replace matching items. That's each item in each list. Okay, it's going to, or list replace, let me just bring up the syntax for that by putting the bracket in. Oops, bracket. Okay, it needs a list, which is the list we're just giving it, the list of column from each column. And then replacements is a list. And the replacement list has to be pairs, which is that table to rows from table replacements. And then you've got the optional do you want to ignore case. If you don't want that, if you want it to be an exact match of the case sensitivity, just delete that step. So that basically creates you your combined lists, and then basically of columns, and then this table from column step reconverts it into a table with the original source name as the headings. Pretty cool. Okay, that works. 5-second refresh. Okay, and then the last one, the List.Accumulate. This is a pretty gnarly one. Okay, so if I go to the advanced editor, let me just talk you through the steps here. All right, in this query, the first few steps are just the standard steps. Okay, source and change type. Okay, then we've got this replacement list, which is turning the replacements table into rows, into a list of pairs, as we saw before. Then I'm buffering that list because I'm going to use it later. I'll show you in a second. Okay, I could have just wrapped this whole thing in a list.buffer, but I've just separated it out to make it nice and obvious. And then I could have just given a list of columns that I wanted to look in, you know, comma with another double quote and the next column name, but I wanted it to be a bit fancy. I only wanted to replace values in columns that are text columns, because actually it errors out if you do this on numerical columns. So I added a little step in here, schema and columns to look in. Okay, so let's have a quick look at that. So if I click on schema, it's going to the change type step, and it's just giving me the schema of the columns. See, this says any.type and text.type. And if I go back to the change type step and I change this to maybe whole number, okay, insert a step, and I go back to the schema, see, this now says integer 64 type, and these are both text. Then I filtered this column and selected the name. So in the next one, let me just get rid of this name reference. Okay, I just basically filtered down to the text type. See, there's a little filter there. And just to grab the items out of the name column, I typed name. So there's my little list. Okay, the columns that I want to look in and replace values in. So that's the setup. So here comes the code. And this is a combination of me Googling stuff, using ChatGPT and a few other things. All right. I'm not going to ever be able to write this by hand. This is some crazy looking code, but hopefully I can talk you through it and you can understand it after the fact. Knowing what to write in advance is very, very hard. Okay, it just comes with experience. I wouldn't be able to write this from scratch without help. Okay, so here we go. What are we doing? Well, we're doing a table transform columns. I'll come back and explain this. We're using our initial change type table, and then we're going to do a list transform on the columns we're looking in. And again, I'll try to break down these two to explain what they're doing. And then for each column, we then want to do a List.Accumulate function. And again, what we're doing is taking the buffered list of replacement values, okay, going through those and saying, hey, for each of these items in the replacement list, do any of those words exist in the text from every record that we're scanning through? So 350,000 records, okay. Have a scan through record 1, change any words that match any of the words. Next one. Scan through the replacement list. Do any of the words match any of the words? Replace them if they do, etc. And the way it works is this replacement pair. So record 0 is the first item in that replacement list. Remember, the replacement list is pairs of items. So it's the first, record 0 is the first item, the item we want to find, and then replacement pair 1 is essentially the second item, the one you want to replace with. So it basically iterates down that sort of table for every item in the 350,000 rows, essentially. Let's just break this down a little bit to try and help explain it. Lots of good content out there. PowerQuery.how, Richter Groot, Mark Proctor, fair few others, Chandeep there on Goodly. It's tricky to get your head around though. So what are we talking about? Well, let me just break down a couple of these. I'll talk about the List.Transform first. Okay, so I've just done a little example here. What's the List.Transform do? Well, what it can do is says, if I just actually open the bracket here, it needs a list and then it needs a transform function, basically a set of instructions of what it wants to do. So I've given it a little list, 1, 2, 3, and then that's the list. And then the transform is for each item, that's what the underscore means in that list, add 1. And here you can see the output, 2, 3, 4. So that's what List.Transform does. Okay. In our case, we want to basically go down the data, the 350,000 records, and do a find and replace for each record. Okay. Before that, though, in the code, there's a Table.Transform. That's the sort of starting point. So Table.Transform, that gets kicked in if you use the user interface to maybe highlight 2 columns like ID and this other column, okay, and multiply them by 10, say, and you get something like this. So again, Table.Transform columns starts with a table, and then you're told how to transform it as a list. So this is saying start with this table called renamed columns, which is just the previous step name, and then for the ID, each item, multiply it by 10. Next item, multiply it by 10. So it's this sort of concept. And then we've combined the two. Okay, so this example here, if we combine it with List.Transform as well, okay, we could say, right, just give me the list that I want to run the transforms on. And then for each column, do something for each row. So it's a way of sort of doing more advanced calculations on a row by row basis for each column in a table. So I know that's a lot to take in. Really you have to just look at the code and try out some examples and see it working. I'm honestly, I'm explaining this to you. I'm understanding it a bit more as I learn to explain it, but it's not something I can just reel off. Okay. So if we go back to the actual code here and the advanced editor. So there's our Table.Transform columns. Change type is our initial table, and then we want to do some fancier things on each of the items. So there's the columns to look in. And remember, the columns to look in was me doing that filter for any columns that were text columns. But you could just pass in, right? You could just pass in a list of columns. So then for each column, we're going to do this. We're going to pass in the text value from every record in that column, and we're going to do a List.Accumulate, which is basically an iterator function. So it goes through your replacement list. If you don't buffer it, okay, if you use the original unbuffered list, then for every iteration, it goes and grabs the replacement list every time, and that makes the refresh take forever. Okay, but by buffering that list of from and to the replacements, it grabs it once, stores it in memory, reuses it. Much faster refresh. Okay, so we take the text value, and then essentially we're going to do a text replace on basically the current text coming in, and then where it finds a match with the replacement record, the first record in that replacements, replace it with the second record in the replacements list. That isn't easy, but it works. Okay, so if I click done, let's go and see it in action. So I'm going to go and change this little drop down to the 350,000 records. I'm going to refresh this one first. This is the single line of code that I did earlier. Okay, right click, refresh. So we're talking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's about 12, 13 seconds. But honestly, when I'm not recording, obviously the recording's using up a whole bunch of time, that's a lot quicker. Okay, about 5, 6 seconds. And let's try this one. This is the one we just did. Right click, refresh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, about 10 seconds, 11, 12. Again, normally 5 seconds when I'm not recording at the same time. I've got 32 gig of RAM on my computer. Actually about 26 available. Office 365, the 64-bit version, that's important. So the more RAM you have, the faster that'll run. Okay, but that's pretty cool. And if you did it, let's say I go back to my source data, and let's say I name this one let's put ABC, okay? And I go back, and I just refresh this, right-click, refresh. Because this is partial matches, all right, it will actually find the A and the B and the C. And we should see apple, berry and cherry show up here in the next second. There we go. All right, let me know what you think. Is that useful? Hopefully, that was a long video, but hopefully you got something out of it. Okay, I'll catch you in the next video. Before you go, check out one of my other videos or playlists and click the subscribe button. Thanks for watching.